Yes.
In the object-oriented programming, so in the last class, we have seen about how to solve a problem. So why we need object-oriented programming? Is it that without object-oriented programming, we cannot solve the problems? No, we can solve. But the why, so it would take like a difficult process for us. We need to do a lot of overhead to solve a problem. The primary reason for going for object-oriented programming is we want to bind the variables and functionality together. So means you want to create your own custom data types. So that's the reason we are going for object-oriented programming. In that process, I told how to create an instance, what is instantiation, what is the difference between old style and new style. So then like what is a constructor, how crucial it will be, how different it is different from a ordinary instance methods. And next I discussed about what is the importance of the overall process and how to create solve that banking problem with the classes. You can see that we have both variables and functionalities together binded. If you create an instance, the instance will have both things features. So that is how I told. Lastly, I told what is a class variable, what is like instance variable. If you want to change anything for the class level, we can use class variables, and in other case, we can use instance variables. That's what we have seen. Now, the next point that we will see is about the method resolution order, also called as the MRO. What is this MRO inheritance? So this is like very, very important thing. So what is this MRO? What it actually telling? First, we need to understand the concept of inheritance. Generally, inheritance means what? The simplest example anyone can think is you have parents. So you have parent and you have a child. So whatever the features are like anything of a parent will be inherited to the child. So this is like automatically. Without you giving any effort, those will be coming. Means what are you defined at the parent will come to the child. So this relation between the parent and child can also be done in different ways. So first and foremost is parent-child relationship or like super and subclasses relationship. Super is something in the top. Subclass means derived from it, like that. And how this works, what is this method resolution order? I will tell you that. First, let's say I want to create an account. So till now we have created an account, right? Previously. Like that, I want to use it. So first I create a very basic class. So, and I write some basic things. So account, this is like class level docstrings. I created a constructor which is not taking any input, the very basic thing. Next, after that, I will add two methods to it. So we have like deposit and withdrawal. So a simple account with like one balance variable and two functionalities. Fine. Next, after this, if I want to create an account, so how do you create an account from it? So first I need to create an instance. If I do like account, I get it. Say if I created an account, so I got the value. So how to test it? Go to the terminal in this directory, navigate. So either you can give the entire path or like you can navigate to the directory. In Windows, we have something called as a prompt hyphen. If I give entire path will be removed. If I say a clear all, it will remove it. So now you see it very easy. Clear and Python, the execution. Now you see it will clear the previous output and it execute it. So you created an account, but you are not printing anything. So nothing will come. If I use like vars to print it, hope you know that if you want to get the instance related things, instance means what? Self. What are all things which are created with self? If you want them within this class, you can use vars. If I use vars, what are all things which are created with self? Only the variables. Class, these are called as instance level variables. So if you use vars, you get that instance level variables. At the same time, for this instance which is created, it will have some attributes. If you want, you can use dir. Dir will give So how many methods are there? Three methods are there. One is a constructor, which you don't even work, but others are like deposit and withdrawal. These two are methods. Whereas self is self.balance, this is a variable. So totally three will come. If I ignore the things which have underscores on either side, so don't you think you have three totally? So three things are there. Two are like methods and one is the variable. So like that you have. Now the point is, from this account, I want to create another account called as a minimum balance account. So instead of doing it, say I want to create a minimum balance account. So I need not define again what is deposit and withdrawal. The minimum balance account means what? When you are depositing, it won't check how much you are depositing. But when you are withdrawing, it will check. So whether the minimum balance is something, if the balance is less than that, it will not allow, right? That's the only extra feature. In that case, instead of writing the entire code again, I can reuse the existing code. So for this to work, did you see that when I created an account, this class, did you see I inherited this class? This concept is called as inheritance. Means when you do the definition like this, whenever you are using, everything will come. So now, as part of our constructor, assume that in this constructor, I'm not defining anything. I'm not doing anything. Even then, as you have inherited this parent class, if it has a constructor, that we need to call. So assume that I am not calling it. So nothing will happen. So, but like, so if I create like a minimum balance account, say I created initially some minimum balance account, same like what we have done earlier. So I want to check it. I created now A2. So nothing will happen. If I ask the DAR and VARs, it will tell same like the above. So it also will have balance 0, nothing. But if you want to achieve that addition, subtraction, or so and so, that's where we need to have. So as of now, I just created a new class. That's it, right? Nothing more. Now let me show you two things. So this is a parent class. This is a child class. Now we know the relation. This is a parent and child. Now, if you want to understand the concept of MRO, means method resolution order, we need to say account dot underscore underscore MRO. Means for that account, what is the method resolution order it will give. So if I can paste it here, you will understand a bit. Means whenever you are asking any information from the account class instance, it will first go to this account class. If there is nothing, it will go to the object class. Means that is a built-in. Whereas if I do the same thing for the minimum order, minimum balance account, in the same fashion, it also executes. But if I can copy the entire things, you will notice it. So did you notice that it will go in this order? Whenever you're asking for something, first it will go to the minimum balance account. If it is not there, then it will go to the account. If it is not there, then it will go to the object. Did you all understand the concept of inheritance? Means whenever you're asking anything, the point is very simple. If you have two classes and two classes are related, if you create a class instance from the parent class directly, it makes no sense. It is just like an ordinary thing. But if you create an inheritance from this inherited class, means from this child class, if you create an instance, even if some method is not defined also, it will work. Just see here, in this, did you define anything? Nothing. So you can even constructor also, I didn't write anything. So initially I'm asking, hey, what is the initial balance? Did you see that I'm asking from A2? A2 was instance which I created. For that I'm asking what is the balance? Did I define anything? Nothing. Now if I ask, it will throw an error. Why? Because when you have a parent class and the parent has a constructor, we should so make a call to that constructor. So this is what you need to be aware. So this is the minimum thing you need to do. So what I did, account dot underscore underscore init of self. So that is what are the exact call, right? I did it. The moment I did it, so see what will happen. Initially it will have a balance and subsequently, now if I ask the DAR, observe print DAR of DAR of this A2 which I created. So when I create the DAR, did you see in this class definition you didn't define anything, but did you see that it also got like balance, deposit, withdrawal? So that's a beauty. Now if I see here, I can do the operations regularly, like I can do a deposit, withdrawals, and everything. Say I have done some operation like in a sequence. If I do, you see now, first I am depositing some 1300, then after that I am asking what is the balance, then withdrawal of 900, then withdrawal of 400. You see, it will just execute. So maybe like if I want after this withdrawal of 400 also, I can ask what is the balance. So finally it will say the balance is 0. It is a typical process. Means though you didn't define these methods, those are coming from the parent because parent class has those definitions. Now I will modify a bit. What I want to say, whenever there is a withdraw class, I want to execute something else. So now I will define. So what I'm saying now, I wrote the withdraw. Did you see in the parent also there is a withdraw, child also there is a withdraw. Whenever you define from a child class any definition, it will not go to the parent. So what is method resolution order telling is, if you ask for any attribute or a method, so first it will check in the local, means from the child itself. If it is not there, then it will go to the parent. So that is the method resolution order. When you ask for any method, where it will check? First in that class, if not in the parent, if not at the object, means built-in. So that is the order. Now if you see, I made a deposit. Did you see here I defined that if the balance is less than minimum, you don't allow. Now we see in this case, as it is less than the minimum, it failed there. Did you see what happened? Please maintain minimum balance. So it won't even do. So after withdrawal of so and so, it won't even allow, right? So that's what you can see. So it won't even allow the last step. So that's what you can see. So what I want to tell in this case is called as, this is method resolution order. If you have a parent and child, if something is not defined, so it will go to the parent. If something is defined in the child, it will prefer that. So remember this every time. This concept, locals are preferred every time. That's what you need to be remember. Now this concept is called as inheritance, where you have a single inheritance, one parent, one child. Let me make a slight difference. So single inheritance, it doesn't mean that every time there should be one parent only. So one parent, one child, like two parents, one child. So like that, we can have multiple things. So let me go for this concept. So where I mention whatever I want. Single inheritance. Single inheritance. So my concept is like, here I want to design a solution which has like one parent and two childs. So this is also single inheritance. Single inheritance means there should be only one parent. That's the main point. So maybe like I want to create one car class. Under that car class, I want to create two childs. The minimum basic things every car will have, I will place there. Under that, if say I want to create something like a Volvo car or some other car, so Aldi car or Audi car or something I want to create. So one parent and two childs, right? Now we see what will happen. If I create a small class, observe. So first I create a parent class. Observe, in this parent class, I define some variables. I told all self attributes should be defined within the constructor only because constructor will be called when defined. So everything, so for better management, if you use only in the last also, all instance variables should be defined in the constructor. So you see here, I pass three arguments. It will create it. Chassis number, engine. So these are the very basics. So for this car class, we have a get chassis, get engine, and a hello world, hello function. So method. Now I want to create a child class from it. So child means what? From this parent, I will inherit. Say like this. I'm creating a class called as BMW, which has car inherited. As I told in the starting, if the parent class has a constructor, we should call it. So this parent is taking these three arguments. Though in this child class you are not using them, you need to pass them because this parent need it. So your parent need, you passed it. And maybe like I added a new feature called as auto gear for BMW auto gear. So and hello world. And you can observe certain pattern. I will tell you shortly. In the same fashion, I created one more child called as Volvo. Volvo is also inherited from the cars. And you see here, it also we are calling the parent constructor and it has auto driving equal to true. So auto drive I give and hello world. If you observe carefully, if I can minimize basic things. So what is the thing which is common in all of them? Did you observe? Every class has something called as a hello which is common. Based upon which class it is created, it is there. But there are some features which are defined in the parent, which every class child will get. Now let's say I defined one of the class. Say I'm if you are creating anything from the parent, it makes no difference. But if I am creating from the child, that's where you can see. I passed some details. I'm asking the dir. So you can notice that CLS Python 03 so and so. You can notice that BMW has these two features. So auto gear and hello. But this get chassis, get engine, all these basic informations, did you see everything is there? Like engine, chassis number and everything. Because that's how it works. All parent features will be coming to the child without even defining them. So now I can ask, so get chassis and get engines. You see here, get chassis is something which we didn't define in BMW. It is there at the parent level, but still I can access. At the same time, auto gear, so get engine is there. That also we didn't define, but we can ask. At the same time, what are things which are there in this thing? So there are two. If you see auto gear, is auto gear present in both parent and child? No. Auto gear is present only in the child class. Then obviously it will execute from it. But sir, hello world is present in both of them. Which one did it prefer? That is a method resolution order. Whenever locals have something, it will prefer locals. So as this class is instance is created from this class, if it has a hello, then it will build from that itself. Hello world. So hope you can see. I am a BMW class. It didn't execute that I am a I'm a cars class. It didn't execute that because locals have it. Assume that if I comment it, if you don't have, then it will go to the parent and execute. Did you see? So that is how it works. If I uncomment it, so as the locals have it, it will get from it. In the same lines, if you create another instance in another way, so get chassis and these are common, but auto drive is something which is only the child has, and hello is something it has. So when you execute, obviously it will execute the Volvo and this thing. So whenever you are executing, so the method resolution works like this. If I can now bring the entire method resolution into picture, so you'll understand that. You see, when I ask the MRO for the cars class, for any class, that class will come first, followed by the object. This is a built-in. For any class that will be going. So I told, right, whether you define the top or not. So when you define a class, I told earlier we used to define like this to say something as a new style class. But nowadays it is by default going. You need not write explicitly. So I mean, it's like there is a basic object which will go. So for the BRO, so BMW, first BMW, then the cars, then the objects. The same thing for the Volvo also. So like this it will go. Now in the same lines, I can ask whether something is part of it or not. See, is subclass. Earlier I showed this concept of is instance, right? Is instance means to check the instance whether it is belong to one class or not. In the same fashion, if a class is belong to another class like inheritance, that you can check with a is subclass. Is BMW a subclass of cars? Yes. Is Volvo a subclass of cars? Yes. Is integers a subclass of cars? No. So like that we need to be aware of this concept of inheritance. Next, so like this inheritance, to understand more, so there is another thing to say. In the single inheritance, so assume that I am taking one more. Um, this is like assume 2. Okay. So in the same fashion, I can create an inheritance from the parent. So child, all these things are there. So I can create like a custom things also. You know the basic int, right? So integers are there. So basic integers if you want to create like a my int. So this is also like something, say like my int if you want to create. So I can take the integer and I can pass to it like inheritance. So now if I create like a m is equal to my int, so it can do the same things. If I ask, so print off, so m dot underscore underscore mro. So mro is something, oh sorry, for the class, right? I need to do my class dot so and so. In this case, you created a class with the this one. If you see in this case, what is MRO? So where it is going? Even for the built-ins or anything, just imagine like object is something which is there in the backend. Anything to which will go. So think like the basic implementation, conversion to C language, everything will be done by that. You can imagine. That is a basic thing for anyone. So even like from this built-ins also we can create like this. So in the same fashion, in the inheritance, one more interesting point you need to be aware is in the inheritance, we have one concept where say like I can create 3 different ways. There is something called as public, private, and protected. Generally, Python OOPS is slightly different from other languages. In other languages, we have like only single inheritance. There is no multiple inheritance. If you see Java or C++ or else. Python is not like that. Python concept is slightly different. So Python has like multiple inheritance also, multi-level inheritance also, and this concept of public, private, protected is very different. These are called as access modifiers or access specifiers, controlling the access to be precise. Means if you define something as a private, you cannot access that attributes, right? That's what Java tells. But in Python, it's not like that. It is to avoid accidental overwriting. So that's the thing. So we need to be aware of. So how we do access are what I will tell. And how we define something as a private, very simple. For any attribute, means like instance level variables or class level variables or like methods or anything, if you start anything with 2 underscores, so we have like 2 underscores. If it is starting with 2 underscores, it's a private. If it is starting with a single underscore, it is protected. If it is not starting with anything, it's public. So till now, whatever you are using, these are all public. But what is the difference of using this? I will tell you. If I define a method within that method, I am calling all of them public, private, and protected. Now, if I make a call class instance, say like this, and now I'm asking to display. So if I ask like print off, so say like I will do like display itself because I do have directly. You see now CLS and Python 03B also. Now, did you see that it is giving all the values? What else is a private value 1, protected value is like 2, and public value is 3 like this. So first of all, why we need like this? I will tell you shortly afterwards. But we can get like this. Within the class, we can access. But now, if I say for this class, if I do a DAR of this B, did you see that I defined three variables and one method? Display you are getting, Z you are getting directly. But did you see Y became like underscore Y? Of course, that is also fine. But did you see you defined X? You cannot access X directly. If you see like, if you want to access, say B dot display I told, that is fine. B dot Z I can ask. So that I will get. If you define like B dot Z and get it. And if you do like for the Y, you can do like underscore Y. Because it is same underscore Y also you can get it. But for the X, you cannot do like this. Did you observe? You just defined like X. But when you're calling, did you see a new attribute came like this? This kind of like crazy. But you need to understand. Means public, protected, and private. So if you want to access the public variable, so it is like direct. Protected also, it's kind of like how you did. You see the concept? It's very different. But sir, within the classes, we are accessing the private variable also directly. Yes, within that class definition, you can access private variables also directly. But outside, when you are accessing private variables, we should prepend the class name. That's the only difference. Sir, why they have done like this means to avoid any accidental overriding. If this concept, if I tell also, the other language people will get confused. They don't even know like how things works. But like this works here like this. At the same time, how this kind of private protected and so works in the inheritance concept. Let's see that. Say similarly, now I am creating a class, derived class. In the derived class, I need to make a call to the constructor. Observe. This time I want to introduce something new to you. So every time we have a class in the super, so we can have like base dot underscore underscore init. So like this, right? And we need to pass self. This is how you define. But instead of that, for the first time, I will tell you one thing interesting. So in the class definition, whichever is inherited, it should go to that constructor. So why you need to explicitly write? So rather, you can go for something called a super. Super is a built-in function. So it will know automatically based upon the method resolution order. What is higher to it? So obviously in the method resolution order, base. So it will go directly to base. So instead of you explicitly giving, you can rely on it. Now you see here, same like what I defined there, I want to define something here also. So observe carefully, this is one of the interview question. So what are the public, private and protected? Here also I'm defining public, private and protected, same variables, different values. Now we see here, what I want to tell is, what will happen if we have parent and child classes, where parent have public, private and protected, and we are inheriting, will all the things will come. So if I say in this class, so Python 03B, did you see now? Did you see now? One interesting point. If I remove this hush of dir, you can see that in the parent class, when you executed, you asked the values 1, 2, 3 you got. So did you see when I asked for the display, I got like 1, 2, 3. So because what are is defined, you got it. In the same fashion, here also we are asking, hey, what is the public, private, and protected? In fact, in this class also you defined XYZ. In this class also you defined same XYZ. But did you see you for the X you got the same one? Means when you have inherited and you have a private class in the parent, did you see the parent class value is coming? This is what interesting. But for the protected and private, what are you defined local is coming? Observe, this is very, very interesting. So till now, what we know, what are is there in the local, that will be preferred. That's what we know. But in this case, you will understand interestingly that though you have locally defined for the private variable, if you have a parent, the parent class value will come for the this one. So this is what makes it very different. So it's one of the biggest entry question which was asked recently. Now let me go for some practical examples. In which case we will go for inheritance. So whenever you have a repeated code, you can go for inheritance. Or one more example is whenever you want to create your own exception. And hope you remember we worked on exceptions. You can also raise an exception, right? You can pass an exception and you can raise it. You see, I raised an exception. So this is how we raise an exception. In the same fashion, if I want to create my own exception class, so what I will do, I will take the same thing, whatever is there, and I inherit it. So means like I will comment it and see here. Exception is a built-in class that I'm inheriting and I'm creating my invalid age exception. Now, instead of saying like, so raise an exception, I can now write something more meaningful. In your project also in real time, you will write your own custom exceptions. So whenever like a 404 error comes, means when you go to REST APIs, I will tell that. For different problems, you will have different errors. There can be project related errors, right? For all these things, you will write your own custom names. Sir, what is that you did? So you wrote a simple class. Maybe right for this class, I want to add something more. Maybe like this time, for the same class, I want to add an attribute. Invalid age means we deal with the age, right? Maybe right, I will take like this. So I define this thing and I'm using it. Maybe like I will comment this part. So it will go down. I have a class defined. I will check whether age is less than 18. So if age is less than 18, I am passing to it. Means I am creating an instance out of it, right? Now, don't you think when you pass any value, it will go through this process? So means like I have like this. See here, age is equal to int of so and so. It will take the age, and if it will pass to this function. So then what happens? If there is an exception, it will go to the exception, right? Because you are raising it. So now we see this practical example. I give 34. It's good. And if I execute and pass 12, it says, hey, you are like so and so. Now at the same time, if you see the MRO, means method resolution order, for this also, the same thing. This inheritance class, first invalid age, then it is inheriting exception. It will take exception. And this exception class is defined in the backend with something called as base exception. And that base exception has an object. So whichever class we are inheriting, what are the things it has? So in that order, in that way, we will use. Hope you understood this concept of inheritance. Now, the last leg in this inheritance is multiple inheritance. This is what makes Python very different. So which is not there in other languages. So means nowadays some languages are also supporting, but primarily the most famous languages in terms of object-oriented programming, they are not supporting it. So what is this concept means? You can have two parents or two or more, and you can have a single child. So how it works? To see that, let's say I define some parent, so class, and within that I have some childs. So the definition is very simple. I define something. You see here, in the constructor I am writing a class. So you know, right, how we call super? Of course, it is not inheriting anything. So you can write explicitly also. It makes no difference. Hope you remember earlier I just did a super. You can do just a super, or like you can explicitly write super of a comma self. So like that I defined and I'm passing values. Similarly, I defined one more class, say like B. B is another class. So here also I will print I am passing. So I told super, if you don't pass also, the same two attributes will go. But if you want also, you can pass explicitly like this. So I defined like B and I'm passing these values. Now I want to create a child out of it. So how do you create a child means? So means like see here. This is a concept of inheritance. You first inherited A followed by B. So this is the inheritance. Now during the inheritance, what we need to call? If you want to explicitly call both the constructors, you can call like this. Observe. You have A is also there, B is also there. Both the constructors need to be called. So then you can call like this. Observe carefully. Now, if I do like a instance, so did you see? I'm just creating a instance from the child class. You know the concept of inheritance means. So it will inherit it, and whenever the child is parent is called, it will call that. In the very first logic, I am not taking anything. Just I created from the instance. So you see Python 05a. You see now what will happen? When the instance is created, automatically constructor will be called. Did you see that only C constructor is called? These two constructors are not called. So that is what happens. So automatically the parent class constructors will not be called. Explicitly you should give, say if I give A and a B, both. Now did you see what happened? So it is giving an error. So A dot so and so is missing something. Means when you give explicitly, you need to pass self. When you give explicitly, you can pass self. If I pass it, now it is working. Observe how the order it is going. Did you see that first it has gone to C, then it has gone to A, then it has gone to B? Yes or no? So why it has gone to A first followed by B? Because you defined A first followed by B. So this is the order in which you maintain. If you see the MRO, say print of this C is the class we have, C capital C dot underscore underscore MRO. If I ask, you will notice. So did you see the order here, how it is going? When you have like multiple childs, parents also, first it will go to your child, which are the C. Then it is going to the A, because A is defined first. Then it will go to the B, means if not in A, it will check in B. If not, it will go to the object. Say, if I change this order a bit, say first I read B, then followed by A. First I wrote B, followed by A. You see, the order is slightly changed. Now, in this case, if I ask, did you see, first C came, then followed by B, then followed by A and object. And if I change it again to the original, so it will be changed again. Means however you give the order, that same way it is executing. And one more interesting part, did you notice? So first C is executed, first print statement, next print statement, and all these things. And in the process, this constructor is also getting executed. And so here you explicitly called both the constructors, right? So instead of you calling, it should do automatically. So for that, we can pass. So using the super. The super concept is like this. Whenever you pass, instead of these two, if I comment them, you see based on MRO, it will execute. Now we see what will happen. Based upon MRO means what? You know this order, right? In that order, it executed. Sir, I don't have a single inheritance. I have multiple. But did you see that multiple parents are also getting executed? So if you write super, it will automatically check what are the inherited parents, and for all the parents, it will execute. So if I do like instead of that, say like if I pass, so like this, right? Earlier we had done. So in that case also it will work. Means instead of you giving explicitly, you can directly pass. So that also works. Say like I added some attributes to it now. So if I add same like this, I added some attributes. You see now. So in the first class I have X. So public, private, private, protected. So Y, public, private, and protected. So protected and private. So like this. So two underscores means private. One underscore means protected, like that. And you know, like, so now after doing this, you can execute it. It will execute it. Now, finally, if I go for the VAS for this class, maybe like I will use, so from pprint import pp. So pp means like in the same order it will give, right? So for this class, what are all the instances are there? That instance variables it will give. And if you can observe carefully, what are all the instance variables it has? So if I can make a note of it, did you see? So X, Y, Z, if I can segregate like that, in Z we have defined three things. Public, Z is public, and this is protected. Protected is coming as it is. But private you defined, it will come like this, right? that I told. In the same fashion, for X also the same way. So X is part of like A. So public and protected will come as it is, but private will be prepended by protected variable of the class name. So like this, right? Everything the same strategy is going on, and you are getting these three set of variables. Now the question is, so can I call this variable? So I have this class private variable, right? So I can call it directly. Say like print of f of sorry f of okay self dot underscore underscore z. So this is belong to this class. So I can get this value directly, right? Within the class definition. So within the class definition or anything, so we can use it. Similarly, I have a parent also, right? What are the parents? This B and A. So this has a private variable, right? So now let me check for this B. So can I access private variables of the parent directly within the definition? Now, did you see it thrown an error? So this is the attribute error. The reason being, you cannot access the private variables directly. So here, if you want to access, you need to access like this. Now, did you all understand the concept of this public, private, and protected? It is not to avoid the previous ones, but to avoid accidental overriding only. So if I do like this, so then it will execute perfectly. You can make a call. So this is what I am trying to say. Okay. So now the conclusions, what we can draw from it. So the conclusions are very simple. Instead of manual executing the constructors, we can use super. That is one thing. And public and private and protected when you have. So whatever is the parent has. So first parent private is there. That will be preferred. In other two cases, whatever is the child class has, that will be preferred. So these are all the learnings that we have. So this is all the concept of public inheritance, public, private, and protected, and how it works. So one more example to give in this process of multiple inheritance is about if you have like multiple things, say like same like in the previous, if I have, see here in this example, I have one parent. Parent will have like constructor with two variables and one method. And you know, if the same method is present in all of them, so obviously child will be preferred, I'm told. At the same time, if some method is not there in the local, it will go to the parent and check. And you see here, there are two parents, right? So similarly, how I define parent 1 and parent 2. Method resolution order also goes in the same way. First, it will check in the child. If not, it will go to the parent and do. So in this case, see here, explicitly we gave two calls to both the parents. Instead of you doing it, you can use super, so that super will do for us automatically. So that is the concept of it, I told. And you see the MRO, how it works also, I told. Just to show you like one more example, I added it. So in the same fashion, multiple inheritance is different. There is another concept called as multi-level. In fact, this is supported by other languages also. Multi-level means you can have like one parent, one child, or simple relation you take. But you will have like multiple in this relation. You see, you have parent A. Under that, you have a B, so which is inheriting from A. And you have a C, which is inheriting from A again. And now D is there, which is inheriting from C and D. You know, there is a standard problem in C++ and Java. You just Google, there is something called as diamond inheritance problem. So that problem is not there in Python because of MRO. Any parent you can inherit from it, from child. So from that parent to that, like anything you can do. And did you see in this case, I am doing super.func. Means in the super class, go and execute that func. I am asking. As it don't have anything super, it don't will execute. And you see here, for anything, if it has a super function, it will execute that. So like that, I'm asking the order to go up. So earlier I worked with constructors, right? This is an example to showcase without constructors. Just walk through it, you will understand it. And the last point in this inheritance concept is there is something called as composition. So this is one you should be aware of. This is one of the design pattern. Design pattern means what? For a standard problem, they are like standard solutions. If let's say there is a river and if you want to cross, there is a problem like crossing a river. How do you cross? Either you can swim. So, but not every case it is suitable for swimming. So some cases like river is very much fast. Then you cannot cross. Then you should go for a ship. And if there is a better way, you can have a bridge. You can go on a bridge. So these are all different solutions, right? So you can understand as a human beings, in which case I can go for a bridge, in which case I can go on a boat, in which case I can swim, in which case I can walk. So like that in real world also, for the computation problems, for standard problems, there are standard solutions. So composition is one such thing. What is composition means like, if let's say I have a parent class, or I have a rocket which has a name and a distance. When you launch it, it will give the display. So if I create an instance also, it works. There is nothing difference. It's a simple class. If you inherit also, it will be good. Now, if you want to create another instance class, so generally what we know, if you create another class, say like I want to create Mars rover. So Mars rover com. So till now we do like inheritance like this, right? We inherit and use the functionality. But there is some scenario where you don't want to do like this. So you see here, parent class is called here and is part of an instance. Means you don't want all the attributes to be directly inherited, but you want it separate. So separately as a one variable, if you want to bind, you can use it. Now, whenever you are defining, you need to use with respect to that. So if I see log, you see in log. So for this, if I create a this one and the MRO, if I see, so how do you see the MRO? So Mars rover so and so dot underscore underscore MRO. If I see it, you will understand that Python 07 so and so. So did you see what will happen? It has no relation directly. If you see, the MRO is straight away. Means you cannot use the super to access that parent class instances or so and so. So you need to make an explicit call and get that instance and make that instance class instance as part of one of the attribute. So if you want to now create and use it, so you should follow this order itself as it is. So in terms of MRO also you understood. In terms of usage also simple. As an attribute you can access. So as an attribute. So as an attribute you get everything. So rocket is an attribute. With respect to that, you can ask the name and distance. See, as I created it, rocket is an attribute. With rocket only, I can ask dot distance, dot name like that. So this is one of the pattern where if you want to isolate the process and if you want to use, this is one way of doing. So like this. And the last point, but not the least in this concept is about the overwriting. So this is what everyone say about. What is the concept of overloading and overwriting? When we are discussing with functions also, I told this concept. It's very simple. If I define a variable called as number1 is equal to 100, and for the same variable, if I define again and say number1 is equal to 200, and if I ask, hey, what is, sorry, if it is number1 and 100, now if I ask what is the number1 is equal to, it's a common sense to say that number1 is 200. Because though you defined 100 first, the latest one will override the previous one. The same concept works because Python stores everything like an objects. So even in a methods also, it will be like that. So in a method, if you are defining two times, so there are two times. In a method overloading will be coming in two ways. Generally in a single class, if you define two methods, the latest method will be taken. Or like when you have a parent and child, with parent has one method and child will have one, that child will be preferred, right? That also we know. So in both cases we have. In the same fashion here also the same thing works. So to state with, I'm just showing this use cases, what are we have. So first to see, so what all things I have. This class has two functions. So whichever is the latest will come. So in the latest, it is taking two arguments. So in the previous one, it is taking like one argument. So ignore this one. So fine. So did you see in this case what happened? So when you ask it with one argument, it throws an error. Though this function is defined, I don't take like one argument, I take two arguments it is giving. So when you pass like two arguments, it works. So this is what the concept of overwriting. But what is overloading? So overloading is not there in Python, but it is there in other languages. So like C++ and Java. So means if you define two methods with different signature, if you pass like two arguments, it will go to this method. And if you pass three arguments, it will go to that method. So like that it works in there. So that is the concept of overloading. So two things should be done with the same, right? That is the polymorphism concept. So which is not there in Python. We have only overwriting. So if you want to allow both one argument and two argument, we can use default arguments. So that is what we know. And similarly, this overwriting I told, right? So whichever is like defined last, the same thing will happen. In this time, the same class is defined, but with two arguments first, followed by one argument. Now in this case, see here, when you pass one argument, it works. But when you pass two arguments, it throws an error, right? But if you want to facilitate both the things in one place, so we can use the default argument. Maybe the second argument, you can make it as a default. If both are passed, take it. If not, you can use it. So similarly, one more thing. So one last case is when two methods are in different classes, so use a private method. So to avoid this one. So maybe take it as an assignment and you write that logic. Take two classes, parent one and parent two, sorry, parent class and child class. In the parent class also define a method, child class also define a method. So obviously based on method resolution order, child will come. If you want to facilitate both parent and child, then you need to define one of them as a protected. Maybe like in the parent, you define as a protected. Then you can access both of them, right? And you see here. So that is an assignment for you. Give a try with different kinds of options. So, but polymorphism can be done in Python. So in another way. So that is concept of overload. So there is some concept called as operator overloading. Means overloading is not possible using methods, but there is another way. If operator overloading means the same operator should work differently in different scenarios. With Python supports very much well, there is concept called as plus. Did you know that? So the same plus operator works differently in different scenarios. So if you pass like all integers, it will do a arithmetic addition. If you pass like all strings, it will do a string concatenation. If you pass all lists, it will do a list concatenation. Of course, it expects all to be of same type because Python is a strictly typed language. But don't you see that the same plus operator is working as differently in different scenarios? So this concept is called as overloading. So to know more about it, so we need to further delve. So in the next class, I will discuss about what are the different ways of overwriting. And there are something called as a magic methods, how to work with it. Everything I will tell there.